Greetings, Statesman. We're going to get started on our lesson on algebraic reasoning. I'm doing some work on getting our chat going. So bear with me. My apologies for those of you guys who are watching this video not live. Take me just a moment to get everything dialed in here. Just so instruction will flow. So thanks for you guys who are tuning in live and are continuing to do so. I can say anecdotally that there are some blocks that are a little bit more prepared, and as we're getting into class, able to kind of tackle the assignments that are streamlined a little bit better. So make sure that you guys are taking very thorough notes. You may see some additional things from this video that you haven't seen from others. As we're working through the world of algebraic reasoning, we're now going to start the world of two-column proofs. So the two-column proof is the only type of proof that we're going to perform in this class. The two columns will look like this. We'll draw a big T. The left side is what's going to say statements, and the right side is what's going to say reasons. This is how we're always going to set all of these two-column proofs up. On the left is where we're going to show our work and say what. And then on the right side is where we're going to explain our work and say why. So left is what, right is why, show our work, explain our work. The key here is that when in math class, when I ask you why, your answer actually should be rather quick and succinct. So on this side, we're going to see one of the four following things. We will see D, P, P, T. We will see definitions, properties, postulates, and theorems. Now, we have talked about how we are going to be men of truth and men of reason. So we're not just going to make up and to say we saw something some way, that's why we think it should work this way. We have to actually have succinct reasons as to why something is true. We're not just going to make it up as we go along and create some sort of a flimsy, individualized experience. We're going to be in pursuit of absolute truth logically and mathematically for something to work. So what's great about this exercise, it is how we're going to state our argument. It's our position on why something works or does not work. It's one of the more important intellectual exercises that you guys will go through. And here's the best part with this course. This exercise right here, the two-column proof, you will never do again outside of this course. Of course, there's the question, why is this important? Why do we use this? How are we going to use this in real life? Well, we're going to learn how to formulate an argument here. Give your what and then why. And it's going to flow through logically with validly and logically with one premise continuing to the next, or even utilizing previously established premises. So let's actually talk about the vocabulary that we have. Now, we've established more definitions for this course. Euclid did so in Elements. He also started to give some postulates, those self-evident truths. But you know what's great is you guys already know a whole bunch of mathematical properties. So let's go first talk about the addition property. The addition property is where we have the following. I'm going to show, oops. Oh, I don't want that auto. How do I make that stop? Ooh, let's try it. There we go. Okay, so we're going to have the following. Where we have x minus 3 is equal to 5. And when you guys have this problem, typically what you're going to do is you're going to add 3 to both sides, right? Plus 3, plus 3. This is the addition property used to solve this problem, right? Or the other way that we see this commonly done is that we see x minus 3 plus 3, right, is equal to 5, and then we do a plus 3 on this side, all right? It's the same result either way, where we're going to have x is going to wind up being equal to 8. Here, we're going to see this performed where it's performed horizontally, but this is the one that you guys are used to is performing this property vertically, okay? Next, we have the subtraction property. How do I get my next bar thing here? Here we go. Go ahead and just delete this one. All right, the subtraction property states we're going to have x plus 3 is equal to 5. Okay? And below, which you guys would see, where you see this minus 3 and a minus 3 right underneath. Or the other way that you guys would see this is we'd have an x plus 3 minus 3 is equal to 5 minus 3. So just depending again how we're going to actually illustrate this being side by side horizontally, the inverse operation being performed is going to be subtraction versus being addition. Okay, let's see here. Next, we have the multiplication property. Multiplication. Oh, goodness gracious. Got some extra stuff going on here. Try to get rid of some of these extra lines for you to clean this up visually for you. Yeah, plus 3. Put this guy's back. Okay. Multiplication. Now I'm going to set this up where I've got my x over 5 is equal to 3. And then my inverse here, operation, is that I'm going to multiply both sides by 3, right? And, really simply put, in order to solve for the next thing, again, 5 times 3 is going to be equal to 9. Then we have the division property, right? Showing that inverse operation, where we're going to have 3x is equal to 5, okay? And of course, in order to solve for x, we're going to divide both sides by 3, all right? Some additional mathematical properties that you guys are going to have here is that we're going to have the substitution property, which does this, is that if A is equal to B, is a conditional statement, then A may replace B. Okay? So it's a direct swap for A for B. Next, we're going to have the reflexive property, which is kind of a funny one. Some of you guys are going to think this is pretty stupid because it's going to be like, yeah, no kidding, Mr. Manners, no duh. A is equal to A. Yeah. The best part is, especially when we start to get into proofs of triangles and triangle proofs, the reflexive property is remarkably important because there's a necessity for it. You guys, I think it might take until then. For the Spanish speakers, the notion of reflexivity is actually rather natural for you guys linguistically. So you guys understand there are reflexive verbs, something done unto itself. The symmetric property, which says that if A is equal to B, then B is equal to A. So this is why you guys can flip stuff around the equal sign. Next, we have the distributive property, which says that A times B plus C is equal to AB plus BC, right? We're going to distribute A times B plus A times C. And last but not least, this is a fun one. It's the transitive property, which you guys are going to recognize this, I hope, from earlier in the chapter. If A equals B and B equals C, then A is equal to C. What does that look like? I hope you guys see it. Which of the deductive reasoning, think about it for just a moment, which one of the deductive reasoning, and I wish somebody in the chat would chime in right here. properties would this be, or deductive reasoning forms would this be? Which law? And this is a syllogism, right? Right? We have one, two, right? One, two, one, two. We have three subjects, A, B, and C, each being used twice. So let's do our first two-column proof in this course. Okay? What we're going to do, we are going to solve the equation 2x minus 5 equals 13. You guys can do this. This is something that's in your wheelhouse from Algebra 1. And what we're going to do here is we're going to justify each step. All right? So we're going to create our two columns as we go through here, right? And the left side, as we know, are the statements. And the right side are the reasons. Now, to do a two-column proof, here's how this works. We're going to enumerate every single one of our reasons and statements and reasons. The very first thing that we have is this, the thing that we have to tackle, the problem in itself. This is our first step, 2x minus 5 equals 13. For 99% of this class, reason number one will be the following. We have this statement, which was given to us, and it just means that's how we're starting. So this is like, we'll have some guys in class, we'll have the given guy, who's going to be so excited as we're doing these problems, and it's, hey guys, how do we start? And they're going to yell, given! It's almost correct. We have to first have our statement. Our first reason will be given. So that's how we start. So let's work backwards. The reason is given, and then we know what our given statement is, which is this. 2x minus 5 equals 13. So how would we solve this, right? So we're going to take our original equation, 2x minus 5 is equal to 13. And then our first step is that we need to add 5 to both sides. Why can we do that? Well, what operation did you just perform? But this is the addition property. So again, this is the what, this is the why, okay? This is show your work, this is explain your work, okay? That's how this works. And that's it. And we talked about this in class before. As guys, sometimes we just don't want to explain ourselves. We just want to just give an answer and just let the world be satisfied with it. And that's just not how this works. It's not how proof works, okay? It is just because. That's not logic, all right? That's just obstinance. So go ahead. We're going to clean this thing up, but since we added 5 to both sides, we have 2x is now equal to whatever 13 plus 5 is, which is 18. And this is the step we're going to call simplify. Now, your textbook does this for the first lesson, and then it stops doing it. What's going to happen next is that we're going to go directly from this step 1 to 3 in the oh, goodness gracious. Uh-oh. Let's go put that step back. And the reason why is that because of addition. So we're going to actually start to get rid of the simplify step. Okay. Number 4, how do we get the x by itself? Well, how do we get rid of the 2? And the way we get rid of it is we're going to divide both sides by 2. And what did we do there? We're explaining what we did on the left side, which was the division property. Now, I don't need you to write division property. You can just tell me it's division. I know division is a property, okay? Getting back to all the stuff that we write on that side has to be from these 4 categories: definitions, properties, postulates, and theorems. All right, so then now we have our solution. We solved it, which means that the x is by itself, which x is equal to the result of 18 divided by 2, which is 9. And here, again, we just did a simplify. In the future, you're going to complete this in 3 steps. Okay? Next, we have another equation to solve. We're going to solve 2 times the quantity x plus 1 equaling negative 4. And we're going to justify each step. Same thing, right? And here we go. We have our statement on the left, reasons on the right. First step, restate the problem, where we have 2 times the quantity x plus 1 equaling negative 4. And this is my given. Now, gentlemen, we've had some properties that we discussed earlier. We could divide both sides by 2, but let's go ahead and just for fun, let's go ahead and use one of the one of the properties that we had down below. So I'm going to write the next step is 2x plus 2 is equal to -4. And what did I do there? But I distributed, right? So that's the distributive property. That's how I make my argument about how I went from that step to the next. Um, as you guys know, as my mother used to say, there is more than one way to skin a cat. There's more than one way to do this thing, okay? Next, we got to get the x by itself. So let's go ahead and subtract 2 from both sides, okay? And of course, our justification of what we're doing is subtraction. But typically, we just skip right ahead to the work being cleaned up and looking like this. 2x being equal to -6, right? And this is where we have the simplify step. We're going to eliminate that in the future. Okay, once we get to class. In fact, I think some of you guys are ready to do it right now because wouldn't you like to do fewer steps? I know you do. You guys are you, and I'm me too. I want to do fewer steps as well. I want to be done with this, right? Divide by 2, divide by 2. To get x by itself, and that was division that we did. And of course, let's clean the whole thing up. And we have x equal to -3, which is our solution that we got because as we explained this, how we made one thing look like the next is that we simplified it. We actually just eliminated all the other work, all right? Last thing, one more, and let's actually do something that's somewhat geometric. You guys ready? Oh, I need to make a little diagram here. This one's fun. So we end in a line. I've got a few angles being formed off of it. This is point R. This is point S. This is point T, P, Q, with angles 1, 2, and 3 being named here. Here's our given. This is baby's first proof. This is a really fun one, guys. RTQ is congruent to angle PTS. And we are going to prove angle RTP is congruent to angle STQ. Oh my goodness, this is going to be a fun one. Okay. Left side is statements. The right side is reasons. We're given this. We're going to make our 2-column proof though. All right. So how is this done? Well, what's given is that this whole thing, RTQ, which is the included, right, 1 and 2, is the same as PQS. That's how we're starting this. So how we start every single proof is we're going to restate what's given to us under statements, RTQ, congruent to PTS, and that was given. Okay, so if you guys ever get stuck, I don't know about you, but when I start doing like some sort of an assignment, if I start writing, this was a funny exercise I'd come into. When I'd start writing an essay in college, I would actually start, and in high school, I would actually start by writing my name and the date and the subject and the professor or teacher. I'd write all this information. I know some of you guys, when I watch you do your homework in class, you actually have to start by writing down, copy down what the assignment is. And it's great. It's one of those things where you kind of just kind of like break the ice, kind of just kind of like, break the dam open and start moving things along, right? So let's just go ahead and get something down there. We can always get number 1 correct, right? Just throw this out there in the universe. Take this guy, stick it in right here, right? And then the reason why is because it's given, okay? So let's prove it, okay? Now, we can't just, effectively what we have is that we know we want to show that this guy and this guy are the same. How are we going to do that, right? RTP and STQ. It's angles 1 and 3 we have to show are the same. What we know is that angle RTP is the sum of angles 1 and 2. And we also have that angle PTS, I'm sorry, RTQ, is equal to angles 2 and 3. All right. And that's the angle addition postulate, right? Didn't we just add two adjacent angles, right? 1 and 2, and then 2 and 3. That's just two adjacent angles. They share a side, therefore they make a greater angle. That's why we can do it. Not just because we feel like it, but because we actually have sound reasoning behind it. Now, we know that RTP, gentlemen. Ugh, it's late here. It's RTQ. RTQ is 1 and 2. My goodness, my apologies. RTQ. Now we know that RTQ is 1 and 2. PTS is 2 and 3. And that they're congruent to each other. So we can say that angle 1 plus angle 2 is equal to angle 2 plus angle 3. And that's one of our properties. Let's go back. That is this guy, right? The transitive property. I have 3 subjects, each used twice. RTQ, RTQ, PTS, PTS, right? 1 and 2, 2 and 3. 1 and 2, 2 and 3. Love it. Transitive property. So they're congruent. Therefore, angle 1 is equal to angle 3. Correct? You know why? I just got rid of angle 2 on both sides. That's subtraction. Right? And then, last but not least, number 5. Do you know what we can say? As we know that angle 1 is the same thing as angle RTP. And that is congruent to angle 3, which is angle STQ. This is substitution. We just gave it a different name. 3 and RTP are the same exact thing, so we just swap them out. When we have accomplished a proof, it means the proof statement is our last statement. So we are done. If we have taken this guy, and this is right here, and this guy, and it's right here, right? Then we are done, and we have correctly and appropriately done our proof, okay? So gentlemen, that's it. Good luck. I will see you in class.